Good morning, Napsters, and welcome to Tuesday. Hope you guys had a nice day yesterday. Trying to get some sunshine our way, but it's not happening yet. We'll give it a couple more days. Okay, so yesterday we did a little introduction to volume. Today we're going to continue that. I'm going to kind of talk you through some things and hopefully clear up any confusions. All right, so as you know, whenever I start to talk about these things, I want to really understand um, what volume is. All right, so we're talking about 3D. All right, we're talking about what is 3D. Well, we know that 3D, we can watch 3D movies, and those are different than things that we watch on television. So that's why this television is only 2D, and this picture to us looks like it's 3D. What's the difference and what's really going on? Well, I think we talked about this before we left, but that D stands for the word dimension. You can also think of it as the word direction. So this TV here only has two dimensions, just like a piece of paper, kind of, only has two dimensions or only has two directions. Whereas this picture, and since it's on a screen, it only has two dimensions, but this picture looks like it has three dimensions or three directions. So let's talk about exactly what those things are. Okay, so in our three dimensions, this image here looks like it has three dimensions. The first dimension or direction is a side-to-side direction. If you look around in your house right now, everything has a side-to-side. You can walk side to side. Okay, well, what's the other option then? That's one dimension. We know we have three. The other option is front to back. That's the second dimension. So I can walk side to side. I can walk front to back. And just like everything here has a side to side and a front to back, including my phone. There is a side to side and a very thin front to back. It's two dimensions. So what's the third dimension? The third dimension, I call it top to bottom. Everything has a top to bottom. So there's really only three ways that we can move in our world and three ways that things can exist in our world. Side to side, front to back, top to bottom. Those are our three dimensions. So when we deal with volume, we're going to be dealing with those three dimensions. I like to use the phrases side to side, front to back, top to bottom, top to bottom. But in math and in our textbooks and stuff, we're going to hear some different phrases. We're going to hear width, so how wide something is, length, how long something is, and height, how tall something is. You can kind of rotate these all around. Doesn't really matter what you call what, but you have to have these three different dimensions. For example, if I wanted to talk about this line right here and say, oh, that's a fourth dimension. Nope, that's just the front to back. That's the length. And I already have length over here. This is not a fourth dimension. This is just the same thing that I have on this side. Okay, so how are we going to, did I want to do that? I kind of forgot. How are we going to use our dimensions to find volume? By doing this. Okay, so let's look at this image right here. And we know we have to find three dimensions. So tell me, for this rectangular prism, what would be the top to bottom or the height? 12 centimeters. Okay, what would be the side to side or length? 3 centimeters. That's side to side right there. And what about front to back? Front to back would be our 5 centimeters. Okay, so we have all three dimensions. There's nothing else to look for. Those are the only three dimensions that exist, except for maybe time. Okay, so what do we do with them? Well, to find volume, we multiply those all together. We multiply top to bottom times side to side times front to back. Okay, and when we multiply them all together, you can use a calculator or you can use the area model, which is going to come up later. I know that 12 times 5 is 60. Let's make the 3 a little bit better. 12 times 5 is 60. 60 times 3 is 180. And we have to be very careful about how we write this. 180 centimeters. And we're going to make sure we put an exponent of 3 cubed because there are 3 dimensions. This is how it should look, 180 centimeters cubed, because we're dealing with 3 dimensions. All right, let's do one more together. All right. What is the top to bottom for this image, or for this rectangular prism? 5 millimeters, top to bottom. All right, what's the side to side? 10 millimeters, side to side, and front to back is 4 millimeters. Front to back is 4 millimeters. All right, so we have all 3 dimensions we need. In order to find the volume, or how much space that rectangular prism would take up, we are going to have to multiply those all together. 5 times 10 times 4. All right. 5 times 4 is 20. 20 times 10 is 200. What's our unit here? Our unit is millimeters. And we have to have a to the third because there are 3 dimensions. So we say this 200 millimeters cubed because we're talking about 3 dimensions. All right. Something we're going to talk about just real quick here is one different way to do this. It's basically the same way, but it's another way that you're going to see it. We can do to find the volume, we can find the area of the base and multiply it by the height. So the area of the base, just like we do with our area model, is our side to side times front to back. So we know that the area of this base here is 3 times 3. So the area is 9 inches squared. That's the flat part on the bottom. The flat part on the bottom is 9 inches squared because we did 3 times 3. So the area of the base is 9 inches squared. And then to find the volume, we do area of the base times height, and height is 2. So 9 times 2 would be 18. Our unit is inches. Unit is inches, and we're dealing with 3 dimensions, so it's cubed, 18 inches cubed. We will talk more about this in the future, but I wanted you to see it, that the area of the base times the height is another way to find volume, but that's basically just the same thing. We ended up multiplying all those numbers together. All right, there's your lesson for today. Enjoy special tomorrow, and we'll see you on Thursday.